of the storage, the kind of storage that they're looking into. Okay, and let's take a small example. I think we discussed the example of a post office, right? Let's discuss that a little bit in detail today, and then jump on to the word count, famous word count example. So just as a recap, we said that the letters come to New York from all the places, and the letters are about 1 million letters, and a single computer or a single person cannot obviously sort it. So they had to go for multiple resources. So they hire about 100 postmen. So all of them are given a chunk of the letters, and those chunk of the letters had to be sorted. So each postman takes a chunk of the letter, right? And he starts looking at the zip code on that letter, and then he puts that zip code into a bin. We also assumed that we have divided the letters state-wise. The zip codes are divided state-wise. So all the letters that belongs to a particular state are put into a bin. So each postman will dump all the letters into a bin. Okay. So up to this point, the moment the postman dumps the letters into a bin, that is called the map of a map reduced paradigm. So what we just did is we're trying to parallelize the computing, or we're trying to distribute the work across multiple people, just in a similar fashion that we try to distribute the work across multiple machines. So if I have a huge data and if I want to process it, just like the letters, I would split it into chunks and distribute it to each of these machines. And each machine will look at this data and do some processing. And after that processing, they put into a bin. They put into some storage. That is called intermediate storage in map reduced paradigm. So that is the map portion of it, right? So I'm giving you details without showing the picture. So I'll come back to the picture a little later. But if you understand this, you understood the map reduced model, the map of the map reduced model. Now, once the letters are in the bins, there are so many bins, and each postman has 48 bins because he is sorting letters for 48 states. Then comes the shuffle phase. The shuffle phase, basically what it does is they try to bring all the letters from all the postmates belonging to one state into a common bin. That is called shuffling, sorting, and merging. So there are three different kinds of operations that happen. So this is again a common sense. We're not looking at any rocket science kind of concept, very simple concept, which happens in everyday lives. So the machines have to do a shuffle, so and then do a sort, and then do a merge. So the output of this would be each state will have a bin, and each bin would have all the letters corresponding to that state. Okay, is it clear so far? Hello? Yeah, good. So please ask me, because once you understand the concept, then rest of the stuff will be a cakewalk. Okay, the rest of the Hadoop framework, the commands, the file system, all that will be a cakewalk. So now we just completed the map. So what did we do? So I had huge amount of data. I distributed it to lots of machines. Each machine is given a chunk of data, and each machine has processed the chunk of data. And the output of each of these machines is put into a bin. And then output of all these machines are shuffled, sorted, and merged into one common bin, separated by some key, separated by some parameter. In this case, we said it is a state. In this case, we said it is a state. So now I have 48 bins for 48 states. So what is my next phase? My next phase is like, let's say I want to just count. So in this case, right? Generally, we'll see how many sales orders have come today, or how many sales orders are there in the last year, right? Things like that. So if I have to just count it, then what I do is I just open the bin, and then I know this is for this particular state. I just start counting 1, 2, 3, 4 like that, and then I'll get the sum. So that is the reduce operation. So now what we just did is that out of those 1 million letters, the output that we have got today is for every state, we are saying how many letters are going from New York. That is the output that we have got. That's a kind of a report. That's a kind of analytics report that we are trying to understand here. So finally, when the reduce takes it, it takes the bin for that particular state, and then one of the tasks that the reduce can do out of several things is it can count the number of letters in that bin, right? So just like aggregation or small report that it can generate. So that completes the map reduce paradigm. So in a big data input is from every map task, and then